Hi guys, welcome back to this concept-based YouTube channel to all my dear viewers. As we can see the questions here, today we will solve B.Sc maths problem, which is a theorem. Let us read the theorem once, and after that I'll explain about this, and based on this we have to prove it over the question says success in this. If V is its eigenvectors of linear operator T corresponding to eigenvalues lambda, then Kv is also an eigenvector of T corresponding to the same eigenvalue lambda. Here K is any non-zero scalar. This is the words which the theorem has stated in this, and based on this we have to prove that Kv is also an eigenvalue vectors of T corresponding to the same eigenvalue lambda. Alright, so this is the question, this is the words which the theorem has stated in this. Now let us use what the theorem has stated in the first. Here it states that V is its eigenvectors of linear operator T corresponding to eigenvalues lambda, right? Let us write first of all this, and then by using this step we have to prove this. Alright, V is its eigenvector of linear operator T, then corresponding to what? Corresponding to its eigenvalues lambda, right? So this is the things that we got in the first, and from that we can make some kind of equations or some kind of things. If V is an eigenvector of a linear operator T, then first thing that will come in our mind, it is small v belong to vector space V, and V does not equal to 0. So this will be the things that will come in your mind whenever V is defined it as eigenvectors of linear operator T. Means based on this we can write it V does not equal to 0, and after that we can write it then if it is not equal to 0. Actually it is cleared from here as well, but we just wrote it so that each and every one of you who are viewing this can understand it better. Then if V is not equal to 0, then by using these words we came to know that it will be T of V, it will be equal to 1, it is lambda V, right? We call this one as eigenvectors and this one as eigenvalues. So this is a statement or the equations which we can write it from this words what it is mean to us, right? This is eigenvectors. In order to be eigenvectors, it should not be equal to 0 and it should be equal to belong to vector space, right? Vector. Then let us write again what are the things that we need to prove in this. It is Kv. V is already an eigenvectors, means we're about to focus on this K, and after we can make K in a proper way, then we have to combine it these two, and after that we'll make the conclusion for this. Alright, here we can see that here K is any non-zero scalar, means we can write it K is any non-zero scalar, right? If it is non-zero scalar, means K does not equal to 0, right? And if it is not equal to 0, and moreover this is a scalar, then you write it n. You can see here v is, since v is a vector, eigenvectors, and it is a scalar, as well as it is not equal to 0, means it is a scalar, right? And k is also a scalar. Let us multiply these two. This is a scalar, as well as it is not equal to 0, and v is also a scalar, as well as it is not equal to 0. After you multiply this, the product that we got after multiplying the two scalar will also be a scalar. It is kv. And the condition of which is interesting that we got it from this, since both of these are not equal to 0, as well as these are scalar, even after you multiply these two, whatever the product that you got, it will also be a scalar, as well as it will also be non-zero scalar. We can say non-zero scalar, right? Means it should not be equal to 0. Thus, same as the problem, or same as the things that we did just before this, we can follow the step now. Here kv is not equal to 0, then we can conclude that kv does not equal to 0. And what is that? Kv is a scalar, right? Kv is a scalar. Is it clear to all of you guys? Then at last we can conclude that d of kv is equal to lambda. Here actually v, only v is there, but here we have kv, means lambda kv. All right, so at last we can conclude that this kv can be expressed in this, or can be written in this, by using whatever the things that is stated in this. And at last we can write it in this form, which is the forms of eigenvectors. Thus at last we can conclude that kv is an eigenvector of, what is that? Lambda, which is the same values of this v. Eigenvectors v corresponding to these eigenvalues, that is same. Exactly what it is asked in the question, so we can prove it now, right? So that's all for the problem which we'll solve today. And guys, I hope everyone can understand this, and those who can understand it, you can ask me in comment sections. And if it is really helpful for you to clear your doubt related to the maths problem that we solve now, then please do like, share and subscribe my YouTube channel for more videos. Alright, thank you.